let's see if I go live. I'm just gonna, these first few seconds are probably gonna be, let's see, do I get audio? Okay, sweet. So, hit my vape. So, what are we gonna do today? The last few streams, I guess like those streams I've been doing, they've been about this game I've been making, but right now I'm making this like raster graphics editor with a friend of mine. But I guess the unique thing about this editor is that we're gonna use some collaborative elements. So like this is a raster editor that you and your friend can like connect quickly and then start drawing. And I'll just like, show an example of that. I have here an instance of it. So I'm gonna take this URL, drop it here, and I'll have two of these. So I'm gonna go like, you'll see it's right there. And in fact, I'm gonna go like this so you can see how it happens in like real time. So I'm drawing on this top part, and this bottom one has like its data reflected with it. And all these things, these three tools we have, fill, erase, and pencil work in like MS Paint. But there is like a unique feature that you can undo, but also this fill. For some reason, most collaborative raster graphics editors that are like MS Paint don't have the fill. The main reason that I think this happens is that very early on in their design, they settle on like a CRDT or a CRDT-like implementation. So like something like last write wins, where they're just like sending pixel data. But the issue with that is that only works if you have the full data about where the pixels are going to be. So for example, the fill, I could have the client render the fill, get all of the pixel values, and then send it to the rest of the clients. But it's a lot of data, and there's going to be some weird latency thing where you're calculating something and then displaying it, but by the time that you've calculated this thing, the state of the canvas might change, and the real-time element of it might not be there. So what we do instead with our program is we have this, I'm calling it a rollback recall type of like repaint thing. So essentially throughout the generation, we're gonna take snapshots of the canvas and then track what like transaction we were handling at the moment of that snapshot. So then that data paired together in a list lets us go back in time to a point where we could use that data. So like, for example, say I'm starting this fill transaction, right? And I'm starting this fill, and then people have sent a draw, some like pencil tool. That pencil tool is gonna affect how that fill is gonna look if the timestamp on that fill is before or the timestamp on their pencil is before my fill. So essentially, by taking snapshots, I can roll back to when from before their timestamp snapshot data is, and essentially I can repaint from there. And that's essentially what I'm gonna show. It's like you can undo, redo, and all that's happening is that I'm sending input information about where the mouse is, what I'm clicking on, and like what tool I'm using. But then that data transactions get sent around and then get rendered. All of it happens like in order, and the result is that you have like a fairly quick like mismatch thing, and it's has this fill tool. And yeah, few problems with this implementation though. First, every single snapshot we're taking right now takes the full data of our canvas. So I'm gonna go into the code, and we're gonna see a few things. So over here, I'm in the transaction manager, and this is kind of the heart of the program. here we have this render loop, render frame, and this is kind of happening every 60th of a second, and it's rendering the frames, and interlacing between rendering the frames, it's processing the rendering of those transactions. And you're gonna see here that I have this check. So I pop from this list of current tasks and I run that immediately. These tasks are just lambdas that can potentially return another lambda. So I'm gonna show you what this looks like. If I go to transaction, I have, I guess I need to go to trans renderer. So like here, so for example, on the render pixel, I return this lambda inside of this list so that basically I pop from that current, where are you? Current task, I pop it. It is a lambda. Sometimes there's an optional next task, which I'll re-push it onto that list if there is. But throughout this whole process of like rendering into the canvas, I'm tracking how long it's been taking. After a certain amount of time of rendering, I'm gonna try to take a snapshot. And here, I'm using 8 milliseconds of rendering. So the way I think about it is every 8 milliseconds you're taking a snapshot. If two people are drawing at the same time, you can essentially ensure that you will get some mismatch, right? If there's going to be consistent mismatch constantly at the beginning, you want to be able to roll back and repaint very quickly. And by having the milliseconds since last snapshot be here 8 milliseconds, what we're able to do is ensure that at most 8 milliseconds, it'll take at most 8 milliseconds to repaint to where you were to begin with to repaint. All that is to say that we're taking pictures of this canvas a lot. And this is like bitmap data, so like pixels and like many dimensional arrays. And as a result, it can get quite slow at very large canvases. So you can see like, if I undo, this drawing speed is fairly fast. So if I go to like even a big, let me make the canvas slightly bigger. So if I make this thing like kind of big, let's do 100. It's pretty fast, right? But if I go to say, let's go to 3,000, slowly, like this. Around here, it's like really slow to draw. You see how it's like, not super slow, but in general, a lot of the lag that we're experiencing comes from taking snapshots of the canvas very frequently. And also at that resolution, like pulling those snapshots every 8 milliseconds leads to a lot of memory being written. What else? There's a bunch of things. So there's a lot of data that's being read from this list, and I want to make sure that as little of that information is stored as possible. So instead of just storing every single snapshot, or just like the whole screen every single time I take a snapshot, what I'm gonna do instead is, I drew a little diagram a couple days ago while I was thinking about how to do this. So we could imagine for this diagram that we have some imagine this is our pixel, just our picture, which is just 4 pixels. And what we want to do is start drawing on it. So we can imagine that we start drawing and our drawing looks like this. So we draw this. What do I do? So we draw that, this 1 pixel. Then we draw a pixel here, a pixel here, and then we draw a pixel here. So we just drew that. That's our whole history. So here I can show like, in our example, we'll be taking snapshots of the canvas as we drew it, and it'll look something like this. Here's it at moment 1, snapshot 1, here's snapshot 2, here's snapshot 3. And you see that it's like a lot of data per thing. So it's like 4 pixels per snapshot. Here, this other way, we only store differences. So we have this, which is just 1 pixel of data. Here we have another just 2 pixels of data. And here we have 1 pixel of data. And I'm representing white. Well, I'm representing no data as white and gray as white. But basically all of this is to say that here we're storing 4 pixels per snapshot, so that's 4 times 3. And here we're storing about 1 pixel, 1.5 pixels per snapshot, total of 4 pixels. So about a third as much as how I was doing it before. And this is for like a very small situation, right? This is like a small canvas. So one thing that's important about how we design this is as we're taking these snapshots, we're gonna eventually want to cull. And that basically just means we have snapshots, and we have a lot of snapshots. So you can imagine like this is our history, and we have snapshots like boom, 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 boom. And say this is this side is the beginning, and this is the end. We have snapshots throughout, right? You really only need snapshots more so in the beginning and not so much at the end. One way you can think about that is like, say our snapshots look something like this, and that we had like many, like boop, 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 boop. And you can just imagine there's a lot here. So I have start, I have end. Is end abbreviated E-N-E-D? End. So you can imagine boom, 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 boom. Those are just snapshots we have. We don't really need many snapshots in the past. When you really think about it, having a lot of snapshots in the past means that like you could get a better one in theory, but only to a certain point or to a certain granularity, right? Because it's like having it be 1% worse of a snapshot isn't really that big of a deal, because being like 100 transactions further in the past than you would for like 1,000 transactions isn't that big of a deal. So actually, in the past you need less, and in the beginning you need more. One way you can achieve that is by culling like halves. So here I'm gonna call this right half So here I've called this right half. Now I'm gonna call this right half of this first half. And then I'm gonna call the right half of the first quarter. And basically that pattern will just repeat up until you have something like this where it's like you have this space. I can't really draw. There it is. And then this space, and you'll see how there's like more snapshots in the beginning than in the back. And a trick that you could use is basically saying, take the current snapshot, and so say you're iterating over the list, right? Take the snapshot that you're looking at and look at the snapshot older than it. If it's like twice as old as you, you're chill. Don't delete yourself. Don't unalive yourself. But if you are like more than half the age of that person, meaning that they're not twice your age in this thing, then you should delete yourself because you're going to become redundant. And the result of that is that like throughout the list, you'll have more in the beginning and less in the back. Simple as that. What's difficult is if you're storing changes in the snapshot, part of that data is used for the other snapshot. So what I'm going to explain here is that how I explained that we're going to track the changes by just storing individual sections of the thing, or just like chunks of the data. It's like this part changed and then this part changed, and only storing that. But when you want to then refresh the screen by changing it with the historic data, how do you get that data? Because you only have those changes. Basically, you will be storing this whole thing, right? So at some point, let's just say we have this full thing of transactions. This whole thing of transactions, we can actually read to see what that state is. So let's say we need to like roll back to 2. So we're rolling back to 2, and rolling back to 2 we would want our picture to look something like this at the end, right? So what we do is we take all the data from and before what we need to look at. So this part, let's put that over here. So we have this data, and what we do is we take this first one, and all the places where we have no data, i.e. white, what we're gonna do is we're gonna move the data from behind it up into it, like so. We don't have data in this top left and this top right one, so what we're gonna do is we're gonna move the data inside of that top left red one into the bottom square, so it's gonna look like pop. And then we're just going to infer that if there is no data, that it was the default color, i.e. white. So just from those snapshots, we were able to rebuild what the screen would have looked like from that point. So we didn't really actually need all that data, which is basically another thing I'm trying to say. This is just a much more efficient way of taking the snapshots, and we can leverage all of the snapshots in history to rebuild the screen. So then that begs the question, so say we deleted one of these snapshots, what do we do? So what we're gonna do is okay, so actually this diagram, this thing that I originally showed was just showing the deletion process. So I'm actually gonna undo some of this so I can show you. So this is the original thing I was showing. And at this beginning, this is what the culling, this first part, this is what the culling of our what we have currently for the snapshots. And what we can see is that this snapshot just gets removed from that list. So like this is a list, and these two snapshots just get removed from the list completely. Excuse me. Boop, completely removed. Simple. I mean, like that's one of the benefits of the design that we had. But you know, it's much more inefficient. So now this is what the culling pattern thing looks like. So we still want to remove that second one. What we do is we take that data and we just merge it into the next one. Like that. So we have this, we merge, putting this one into here and this one into here, and we get this. So you'll notice that this one is green. The reason why that's green is this snapshot 3 is newer. So that green pixel was actually overwritten by that blue pixel. We don't actually need the data of that blue pixel because it got overwritten. So we have to just replace it with the green. So that blue doesn't replace the green stays. The data in that thing that it was originally in stays. And then you get this. That's the gist of the new snapshot system that I want to start using, because as I was showing you, it was much slower on the larger canvases, and I think by only recording changes, we can reduce that lag by a lot, I think. All right. So just to show boop, 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 laggy, if I make it bigger, I think it'll show even better. So here's like a 6,000 by 4,000. Will it even paint? Oh. Let's go into virtual canvas. Let's see if it... Okay, let's make it big. And bigger. And then bigger. Yeah, okay. See if there's lag. Oh, yeah. So this is what I was talking about with the lag. Boom. Oh, look at that. It's terrible. And I can show you that the snapshots are what is causing this by, if I go into my transaction manager and I change this to like 128, you'll see I have much less lag while I'm drawing. You see? Much less lag. So the snapshotting is what's really slowing it down. And that's what we're gonna fix. So I started this a little bit. And I made this like class for snapshots. So it kind of, I mean, I was writing this just kind of like drafting some thoughts, but looking further at it, I realized that there's two things that I need to design for this. I guess like two components I need to design, not one. So the first component I need to design is the tracker, and the second component I need to design is the snapshot. So first, let me show you what I mean by that. So we have our screen, and we want to be tracking individual changes. So say that we've drawn something like this. We're gonna track like grids of the region. So you can imagine like the grids might be like this. And that like if a grid has some stuff in it, it gets filled in like so. So these will get stored, these regions. Maybe that one. It's like a CAPTCHA, I'm not sure. Maybe that part's in it. But yeah. This is its own thing, capturing this data. And then when this gets transformed into a... Oh no, something break? Oh, it just takes so long to re-snapshot. Basically, if this gets, this will at some point have to get turned to a snapshot. And the result is all these pixels that weren't drawn just stay. These get duplicated, or maybe we'll have like a double buffer where we will render onto 2 of these, and then if there's a change, we'll like take that one off and then repaint like onto it, and then like have it like that. Might be a little bit more fast or faster. What else? Yeah, so we have the tracker, the change tracker, and then the snapshots themselves. So in Snapshot Manager, I mean, sometimes I'll write a class which is like a thing that controls everything, but I feel like in this case, I'm just gonna make classes that these 2 things control. By 2 things, I mean the transaction manager and the virtual canvas. They'll control, and it'll just replace some code in different places. Like if I go into the transaction manager, I'm managing the snapshots in here. So let's look at all the places. So here's for syncing the canvas. This is syncing a canvas if there's like a mismatch in history. Yeah, just snapshot stuff. Then this is taking a snapshot, and this is reading the state. This is for like starting the server, which is a little bit, or starting the client, which is a little bit different. But yeah, so that's basically all the snapshot does. It's these 2 functions: take snapshot, sync canvas, and I just store them here. And then when it comes to how the virtual canvas relates to those, there is there's set new virtual canvas. So like the new virtual canvas is what I'm like shadowing the name of, or I guess not shadowing. It's what the variable for the snapshot is inside of virtual canvas when I'm talking about it. So like those are snapshots of the virtual canvas, but the virtual canvas it's just a 3D array of numbers. Whether it's a snapshot, whether it's a virtual canvas, it's just like eye of the beholder. But this it's new virtual canvas, and I think it really is just set, and then this one for pulling. But these 4 functions, I'm gonna pull out into these objects and then have them be controlled via the virtual canvas. I think the functions that I'm going to have is this first one that does this change tracker. You might call me stupid for this, but inside of the virtual canvas class, I have a field called virtual canvas, which is that 2D array of, 2D arrays of arrays, so like a 3D array. And it represents like the pixel values of the canvas, and it's just for faster, like, basically sending over uint8 arrays or whatever. The data that is inside the canvas is like really cumbersome because you can't really do your own. There's a lot of garbage that you can't collect on your own or manage on your own with like an object pool, and by having these virtual canvases, like, you can move stuff around very fast. But this is like every single time you're setting pixels inside of the class virtual canvas set pixel, you're changing a pixel value in this virtual canvas. So this one, right? And every single time you do that, we need to track. So this change tracker. So let's just like start. Let's go into Snapshot Manager. So this is like the snapshot thing. These functions, but I'm actually gonna just like keep this here for now to like reference. I'm just gonna start writing some new stuff. Maybe I'll keep chunk size like that, but first I'm gonna do a change tracker. What do I height width? I guess I'll pass in a height and a width. Okay, so this is what I'm gonna have to do. I need to do something like this, so I'm just gonna straight up copy this. And then I'm just gonna rename this to canvas. Is this how you... Is this how you make a, is this how you do it? Is that not how you do it? Because what I really want is, yeah, wait, actually, how do I do it in, I think I just need to make a 1D array for now. Like this. Wait, damn. Arrays in JavaScript. I'm like blanking. So this dot canvas equals array. I'm just gonna do it the goofy way. Right? I think that's how I do it. Snap height. And then I'm gonna push. Push a new array. Okay. Da-da-da-da. And then in each one of these, oh, I know what I'm gonna do. I am brain dumb. What am I doing with the empty list? I actually need to go like one less than snap height and then one less than snap width, because there could be a chance that the parts on the edges aren't like a multiple of chunk size. So I'd have to make those smaller maybe. I mean, at the same time, that does make things more difficult. Yeah, okay. I mean, honestly, I think it's chill to just like make all of them. Yeah. So I'm just gonna go like this. Array, and then fill each one with. What am I gonna fill each one with? 256 by 256 square of white. So I need to have white here. White. Oh, okay. Watch this. Let me just use my brain real quick. So if this initializes a height by width thing of white, if I go chunk size, array, chunk size, take this. Oh, okay. Actually, I have to do it similar to how I have it here. So instead of man, how do I convert this? Comma. This is ridiculous. Does that make sense? So apparently this is right. I guess so. And you have your double and change tracker. I believe it. I don't need this anymore. Chunk size, canvas. So we have canvas. We're gonna have double. Would having double even change anything? Because when I remove, I'm gonna have to recreate it anyways. So what? I'm gonna have to. Interesting. It's a tricky thing because it's like have to. Those are where you have them. You take those off. Okay, yeah, it doesn't matter. I don't really need a double one, so I just need one. Okay, so that's what it's gonna shape. That's what its shape gonna kind of look like. You're gonna want to be able to change its size. I'm not gonna call it change size. I'm gonna call it set size. Set size with height. I guess I'm doing width first. Yeah, I do that everywhere else. With height. I don't care if that's in a different order. So set size with height. So I basically want to just copy this. And this is a perfect situation for ChatGPT because I don't really want to think about how to write that. All right, so ChatGPT. Let's put this window here so you guys can see it too. Full screen. And I'm gonna ask it, can you also change the size of, what did I copy? Oh, of let's here. Can you also change the sizes of this canvas in a similar way to how change factor is done? Failed to generate? What's wrong with you, buddy? Oh, maybe he's sick. Looks good to me. So new snap width, math ceiling, chunk size. Okay. If y is less than snap. height and the x is less than snap width. Preserve the existing chunk. Otherwise, you add another one. New change tracker. Or false. All right, looks good to me. Set the sizes of it. And then now, we have a build snapshot. Yep. Okay, so I have a build snapshot thing here where I'm cloning stuff, but I'm storing it in a map that I'm indexing into, but I think it might be better to just store it in an array, like a 2D array, and then have like blank lists in those spots. And yeah. Build snapshot. Yeah. So I won't even need a snapshot class. Maybe I will. Okay. So I guess I won't need these things. I'll just write like functions that I can, like 2 functions that I can call, maybe. So first, I guess build snapshot's gonna look something like was this thingy menu. I'm gonna copy this. Like that. Inside of the snapshot data, I need to know what kind of
not what kind, but what size the snapshot was. And since yeah. So this is going to be const changes. That's true. Oh, I need to do a track change. Go check transaction or virtual canvas. I want to see if the way that I set the pixel it might be faster. What I can end up doing is just making a list of these positions and then sending that in with the color, and should be pretty fast, maybe. So next in positions element x y. Equals true. And then I need to set the pixel in the canvas. This dot canvas at the same spot. So that spot, but at y mod. Which one's freaking mod? Y mod chunk size. And x mod chunk size. Why is the bracketing like that? It's terrible. It has to equal this color. Okay. Now what? Now what? So now we have set pixel. Now we have to still finish build snapshot. So if the change tracker is true there, am I setting it correct? Y, X. Okay, so if the change tracker is true there, then we could use that piece of the canvas. Or it's false. But I need to write a clone function. Alright, this is where I'm going to start writing functions. So like, we're going to have I don't know if this is good or not, but chunk length. Maybe I'm doing something so dumb, like so dumb. Array from chunk. Array from chunk 0. Y. Chunk Y X Y. Changes and then return. Bonk. And build snapshot canvas X Y. Clone this chunk of clone that chunk. That's the changes and return an object where the first thing is changes and the second thing is height and the third thing is width. And And this thing is this whole thing. Like that, and like that, and like that. Okay. That seems coolio. Fuck it. Okay. So now we build. And then let's write a function accept old changes. Old snapshot, new snapshot. And I'm going to iterate over this new snapshot. Actually, I think I'm going to call this Y, not Y chunk. Ah, fuck you, man. Y, escape, tab, enter? Wait, why can't I? Okay. For loop. I want to call this Y. Enter. Y. Enter. Tab. Oh! New snapshot. Dot length. So first, let's do a const y min equals math.min old snapshot.length comma new snapshot.length, and then const x min equals I'm gonna copy that, put that there, change these to x's, call this xmin, and then now I have x and y, format, hit enter, if not new snapshot, I'm just writing Python, if not new snapshot at y or an x. So if there is a snapshot, right? If there's something there, continue. So then I know there's something there. Something has to be there. No, something can't be there. So if something can't be there, if this or not old snapshot y x, I might have to put a comment there. Usually if you have like those binary things where like one is negated and the other isn't, it's like you're never gonna remember y in the future. So there is an old snapshot there. There is a one that's new. So now I have to do new snapshot at y x equals equals old snapshot at y at x. Old snapshot at y at x equals false. You know, just pulling it forward. I think the reason why I want to do this is because at some point I want to do some sort of like object pooling for these chunks, and you can get cases where you just screw up and you're like editing data that you didn't want to edit. So like, you know, moving something and then undoing or unsetting where it came from will like completely ensure that that'll never happen. But honestly, this looks chill. I mean, it seems like this accepts the old changes. I wrote an accept old changes here, and it was terrible. So I can delete all this. So okay, fine. So I did change tracker. I did accept old changes, and then the last one is update state, and this is going to be a list snapshot list. It's going to be a list of snapshots. I'm going to ensure that this list is only the list that it can use to pull from, and how am I going to do this? What's a good way of doing that? Let me go back to what the task was. So right now, for update state, I need to solve the problem where it's like, okay, so say I need to refresh from state 3, right? How do I build the whole state? So basically, how do I build this whole state from this? And you know, you're gonna have your the size of it. You know for sure what the size is because it's gonna be the size of the last snapshot, and you're just gonna go back in time and you're gonna check each one to see if like this is essentially the problem, right? Like you don't need to check this one once you've gotten it, right? So then when you go into here, you only need to check this one, and this one. Once you've gotten this, you don't need to check these two. You only need to check this and this. And continuing until you have no more to check. We either need to track what we have seen. And so, well, we need to know we need to know how many more, if any, we need to do to look forward in. Which ones are the ones that we need to set? And I think that's it. To know how many you need, what we could do is initialize like some sort of set or some sort of map where I can like easily search. Like I can get the amount of entries in it easily. I can delete from that maybe fast. I don't even know if that's pretty true. I should be able to add into it a key to see like, oh, that's still in the list. It doesn't really solve the so it solves the problem of like which ones we have to look for, right? So from that map we can tell which ones we need to look for. The only issue I can think of is how we make the keys. one way you can make the keys is doing some sort of like comma separated string. So you take like the first index, the second index, and you do like a comma separated string. Issue with that, I mean, the only issue I have is like making strings is slow. You're gonna have to be concatenating n squared amount of those strings. There are methods for mapping I think it's called Cantor pairing function. There's this, which I can use. I mean, it's kind of a headache. How else would I be able to do it? I could do some like recursive function. Where I go like okay. New height equals snap. Okay. So latest latest equals snapshot list dot get snapshot list dot length -1. What's funny is it might even be more elegant to do like a shift pop, a pop and then append, or a push, pop and push. Yeah, getting from the end of a list. What else? I need to let me edit the title of the stream. Okay, so I have the latest one. I'm gonna say const new height equals snapshot equals latest dot length, latest dot changes dot length, latest dot height, const new width equals latest dot width. Const changes. The latest changes is going to be latest dot changes update state for latest dot changes dot length. Let's call this Y. And then let's do a full copy of that, call this Okay. While if there is changes, then what you're gonna do is this dot set size latest dot width latest dot height. Now I don't need this. If latest dot, if there is it, so then clone that chunk.
Clone chunk. Latest dot changes. Continue. Otherwise, so you're gonna continue. So then that means there isn't a change at latest changes. So then let change equal false while not change let list index equal snapshot list dot length -2. If not change even after this, so if there's no change even after this, that means you just continue. Otherwise,
this dot chunk, yeah, this dot chunk equals clone chunk of change. So if there is no change, what do I do? So while there isn't a change, snapshot list index. Snapshot index minus. Const current snapshot equals that one. If y is greater than or equal to current snapshot dot length, or x is greater than or equal to current snapshot dot 0 at y dot. I guess I had to do it at 0. Well, I mean, at this point, yeah. So dot length. If that or that one is true, that means that we're just completely out, and that any snapshots from before it won't even be able to like push data into there. So that there's no way that there's even data there. So that break. So you're gonna break out this while loop. While we're in here, const current snapshot equals break out of the while. I need change to be I need a change to be false. Break. Oh, but I'm not setting change. Break. Change is false. I break. Otherwise, if change. Otherwise, change equals current snapshot break. Otherwise, change equals current snapshot. For this, instead of continue, I need to put a white. So I have this code here. There's no data. Boink. Okay. So let's see. If the change is not chunk, otherwise we get change equals dot changes at y at x. Then you're gonna check that again. Do the thingy-mabob with the bop list index minus. Okay, cool. Damn, I'm tired. I'm gonna take a break. I might come back on. Maybe I'll come back on tomorrow and I'll finish this out. But thanks for watching a lot. All right, bye.